All right, let's get into it. We're not just talking about an AI that can write a decent email anymore. Nope. Today, we're diving into a massive breakthrough that's actually teaching AI how to think. This is the real story of a revolution that's happening right now in machine reasoning. So here's the big question, right? How in the world do you give a machine that aha moment, that spark of real insight? Well, it turns out it's not just for humans anymore. Let's unpack the science that's turning this from a philosophical question into an actual engineering reality. But first, to really get why this is such a huge deal, we have to understand the problem. For years, there has been this massive, frustrating gap that has completely stumped the brightest minds in AI. I mean, we've all seen large language models do some incredible things, right? They can write poetry, summarize dense articles, even whip up some code. But here's the catch. There is a huge difference between sounding smart and actually being smart enough to solve a totally new, complex problem from scratch. And this really gets to the heart of it. On one hand, an AI is fantastic at tasks it's seen a million times, like drafting an email, but ask it to solve a novel math proof or debug a super complex piece of code it's never encountered. That's where it just historically falls apart. That is the reasoning gap. So, how do we finally bridge that gap? Well, the answer is in this radical shift in how we train them, and it's called reinforcement learning. And believe me, it is proving to be an absolute game changer. You can actually see the whole story in how AI training has evolved. We started by teaching AI to align with what humans liked. But this new frontier RLVR is totally different. The goal isn't just for the AI to be helpful anymore. The goal is for it to be provably, factually, 100% correct. So what even is reinforcement learning? The easiest way to think about it is like an AI playing a video game. It tries a move. If it scores points, boom, it gets a reward. It just does this millions and millions of times until it completely masters the game all by itself. Now, RLVR takes this to a whole new level. The score isn't subjective, like whether a human thinks an answer feels right. Nope, it's based on cold, hard, verifiable facts. Did the math proof work out? Yes or no? Did the code compile and pass all its tests? Yes or no? It's a binary, totally objective scorecard. No opinions allowed. So what does this actually look like when you're training one of these models? How does this process forge a mind that can reason? Well, it turns out to be this elegantly simple, powerful loop. And here it is. It's just a 4-step cycle, but it's incredibly powerful. The AI gets a problem. It tries to solve it, step by step. Its answer is automatically created by a computer verifier, and then it gets a reward for being right. It repeats this loop millions upon millions of times, getting just a little bit smarter with every single attempt. And listen, this isn't just a cool theory. This method is already producing a brand new breed of AI with capabilities that are, well, frankly, they're just astounding. We are seeing this in action with some major recent models. You've got OpenAI's O1 and the open source DeepSeek R1. And they've both proven that this technique lets them perform these long, sophisticated chains of reasoning that were basically impossible just a short while ago. And the impact is already staggering. These new reasoning models are just shattering old boundaries. They're excelling at advanced coding, acting like autonomous agents that can actually use tools, and they're even tackling these profound challenges in medicine, science, and even robotics. The core insight from the researchers behind all this is just wild. It's that a simple, clear scorecard is enough to drive an AI to superhuman competence. It doesn't need a million complicated rules, just a well-defined goal and the freedom to figure it out on its own. So, as you can probably imagine, a breakthrough this huge has kicked off some pretty fundamental debates about the future of AI and how we should, guide its rapidly growing intelligence. Okay, one of the biggest debates right now is this. Should we reward every single correct step in an AI's thinking process? Or should we only reward the final correct answer? Rewarding the process is probably safer, but just rewarding the outcome could lead to more creative, totally novel solutions that we'd never think of. And here's another critical question researchers are wrestling with. Is this technique truly teaching these models to generalize, to solve problems they've never seen before? Or are they just getting exceptionally good at memorizing the patterns from the millions of problems they saw during training? It's a huge question. But let's make no mistake, the grand vision here is absolutely massive. Many of the leading researchers in the world believe that just scaling these techniques, giving the AI more data, more complex problems, and more computing power to learn, is one of the most promising paths we have toward the ultimate goal of artificial superintelligence.
And that leaves us with a question that isn't just for scientists, but for every single one of us. As we stand here, right on the edge of this new era of artificial thought, you have to wonder, if we can teach a machine how to reason, then what can't we teach it to solve? What problems, what grand challenges that we once thought were impossible are now suddenly within our reach?